what is the ratio in which the line segment joining 2, negative 3 and 5, 6 is divided by the x-axis? Please remember, whenever a line which is made like this, okay, this is the line, it is divided by the x-axis, and you know that x-axis is a horizontal line. So it means this is the dividing line. So it means this is dividing this one. So this is 2, negative 3, let's say, and this is 5, 6. Okay, we have just assume that. So this is the point. Whenever the point is on the x-axis, so we know that y is equals to 0. If it is on the y-axis, then x is 0. It is 0, y. But right now it is on the x-axis. Now, because we know we have to find out the ratio, for ratio, we always use the section formula. So what is the section formula? First of all, I will write it. P of x, y, that is equals to m x2 plus n x1 over m plus n, comma, m y2 plus n y1 over m plus n. Now, please remember this thing because the time limitation is there. Y is 0 here because the coordinate is x, 0. When y is 0, always only take the y point. Do not include yourself in the x portion because y is 0. So directly take y. So 0 is equals to whatever the values here, m, which is whenever we have to find out the ratio, always take ratio as k ratio 1. Okay, in a single equation, you can't take two variables. So 1 is 1 and 1 is k. So k is m, y2. So this is x1, y1, this is x2, y2. So this is this plus n, which is 1, and what is y1 minus 3 over k plus 1. So final equation is equals to 0 is equals to 6k minus 3 over k plus 1. This is in division. When it changes its side, it becomes in multiply with 0, and 0 multiply something is 0. So 6k minus 3. So when you solve it, it becomes 6k is equals to 3 and k is equals to 3 over 6, which is 1 by 2. So the ratio will become 1 by 2. Okay, 1:2 is the final answer, right? Now moving to the next part, next question. A point x, y is at a distance of 5 units from the origin. Please remember one thing, that whenever we have a point which is x, y is at a distance of 5 units from the origin, it is always the radius for the unit circle, or for the unit circle, it is the radius. So radius is 5. And we know that they are saying how many such points lie in the third quadrant, right? So r is equals to 5. Now we know that point x, y. So we know that it is of the circle only. And for the circle, we know the equation x square is equal plus y square is equals to r square. This is the equation of a circle. You should know this, right? Now, this comes from the Pythagoras theorem that I will tell you later. Okay, let me tell you little. What is the thing? So when we make a triangle like this, it's a perpendicular. We know that this point is on the x-axis and we don't know the value. So this is x. This is parallel to y-axis and we don't know which point lies on the y. So this whole distance we take as y. When you apply the Pythagoras theorem, now, it becomes x square plus y square is equals to r square. So x square plus y square is equals to 25. Because it is in the third quadrant, you know that if x is minus 3 and y is minus 4, then also you will get 25 after putting in this. If y is equals to minus 4, x is minus 4 and y is minus 3, then also you will get 25. Third quadrant, both are negative. Please remember. If x is equals to 1, negative 1, and y is equals to negative root 24, then also you will get the same value. If y is minus 20, x is minus 20, minus root 24, and x is minus root 24 and y is equals to minus 1, then also you will get. So there are many values you can put. So infinitely many values we can say as x and y, which gives me the answer as 25. Okay. So I think this is clear. Now, let's have a next question. So infinite many, right? In triangle ABC, D is parallel to this line is parallel to this line. We know the similar triangles thing. This line, when it's parallel to this one, so this over this is equals to this over this is equals to this over this, right? So in this triangle, which is in the question, it means CD over AC is equals to CE over BC is equals to DE over AB, right? It could be CD over AD also, CE over BE also. But what is required right now, because the bigger values are given, AB is given and DE is given, according to that I have taken. Now, whatever the values are given to you, this ratio is given to you, and BE and EC is given to this ratio. So I'm using these two only. So CE over BC is equals to DE over AB. Now, what is CE? CE is given to you already. C. What is BC? The addition of this, because BC is this plus this. So both values are given, which is B plus C is equals to DE, which is X, and AB is A. Now we have to find out for the X, just cross multiply. So CA over B plus C, right? So the value is AC over B plus C, which is the answer is B, right? So I think this is clear to you. Now moving to the next question. It is very, very easy. Just understand it from here. This is a tangent because it touches the circle at a single point from the outside. So it's a tangent. Tangent always makes an angle of 90 degree with the radius. That is the theorem. This whole is 90. Now what they are saying, chord PQ, this is chord PQ, makes an angle of 50 degree with the tangent. Mean this angle is 50. This whole is 90. This is 50. So how much is this one? 40 degree. Now if you will see this triangle, OP is equals to OQ because they are the radius of the same circle. In a triangle, when these two sides are equal, their front angles are also equal. Isosceles property of a triangle. So this is 40, this is 40. Apply the angle sum property. 40 plus 40 is 80. And we have to work out for this angle because they are saying angle subtended by the chord at the center. So at the center, we have to find this value. So angle this plus this plus this is equals to 180. 40 plus 40 is 80. And subtracted from 180 it is 100 degrees. So this angle is 100 degree. Okay. So I think it's clear to you. Okay. Now moving to just a second, I will rub it because this is not required. Now moving to the next question. It's very easy. Quadrilateral PQRS is drawn to circumscribe a circle. Please remember, whenever a quadrilateral circumscribes a circle, the opposite side sum is always equals to QR. This we have learned when we know that a tangent drawn from the, so they are equal. So this portion is equals to this portion, this portion is equals to this portion, this portion is equals to this portion. So we know directly that whenever a quadrilateral circumscribes a circle is inside the quadrilateral, opposite side sum is equals to the other opposite side sum. So PQ, which is 12, SR is 14, PS we have to find out, that is SP, and QR is 15. Let's solve it. It's 26, SP plus 15. So SP is equals to 26 and 15, which is 11. So the answer is 11, right? Simple. So please remember the theorem so that you can find out the answers fast, right? So thank